Please clear everything you have. Do not forget parentheses. This is a rational function. Requires parentheses around the top and parentheses around the denominator. Always. So negative 2x plus 10. Close the parenthesis and divide by in parentheses by x plus 3. Close the parenthesis. The calculator is not as smart as you are. It does not know anything about horizontal asymptotes. What was the horizontal asymptote for this function? So that is, thank you. So that has to be as a separate line. Let's say we use a standard viewing window, standard 6, and let's graph the function. It's coming from approaching negative 2 down to negative infinity. It does not show. It does not show x equals negative 3, which is a vertical asymptote. I have no idea how to do this with the software. But the older calculators should present the vertical asymptote. Do you see the vertical asymptote?
Mine shows one poly.
No, the vertical asymptote. The vertical. No calculator shows the vertical asymptote. Oh, I think you have to put this negative, this symbol here. So now zoom 6 should work. Oh, here's the negative. Oh, that's negative also. So the first negative has to be this symbol. So if you start anything with a negative, it has to be this symbol. If you have 3x minus, it's this symbol. But if you start with a negative symbol, it has to be that negative. Yeah. So now if you want to zoom out, let's see a better picture. You can. So let's change the viewing window. Let's say to negative 40 to 40 with a scale of 10 or 5, better. And let's say negative 40 to 40 with a scale of 5. Say it again. Oh, sorry, thank you. And let's graph. And let's see what happens. So now this is a better graph. It's better, easier to see, and it shows the horizontal asymptote. So as you see, it's coming from approaching negative 2 to negative infinity, from approaching infinity, crossing at 10/3, crossing at 5, and then going towards negative 2. Now this took us, I don't know, 10 minutes or so, 15 maybe. Now let's look at type 2, and then we'll come back to more examples. And I would like to show you some applications of this. For type 2, there is only one difference. And it says only the horizontal asymptote. So let's write that for type 2. The horizontal asymptote, lucky you, it's always 0. Yes, Rachel?
Can I see step number 3 of it?
Yes, of course. No. Define the behavior?
Yeah.
Yeah, find the behavior. So remember, when we talk about end behavior, we mean this. Or we mean this, or this, or this. But now when we talk about behavior near the asymptote, we mean this, or this, or this, or this. That's what we mean. So find the behavior of f of x near the vertical asymptote. And how we did that? With those tiny numbers, left and right of negative 3. We picked negative 3.1, I plugged it in here. Just for the sign, I got negative. Then negative 2.9, I plugged it in here, and I just got the sign positive. That's item 3. Better?
Yeah.
Okay, so let's write the note. The only difference is, so note. Okay, did I start this? I think I did, right? Yes, I did. Okay, thank you. Okay, note for type 2. The only difference is the horizontal asymptote is y equals 0 always. For type 2, the horizontal asymptote is always y equals 0. Okay, ready? So let's take a look at, let's say, f of x. X divided by, or x minus 1 divided by x squared minus 4. What should I do first immediately right away?
Factor the bottom.
Of course. Because I need what? Before I start, I need number 1, which is the domain, yes. Yes, and the x-intercepts in a moment, but the domain is, if I don't factor the denominator, I will not know the domain. Okay, so what is the domain? Without 2 and without negative 2, correct? Good. So negative infinity, negative 2, 0 in the middle, 2, and infinity. And I will have this symbol or any symbol you would like. You can write U for undefined, whatever you want.
So it's negative infinity, negative 2, and then you.
Yes. Negative 2 to 2, and then union 2 to infinity. So for the scope of the graph, if you just present the chart, I'm fine. Just write on the side whatever you want. See, it's very clear that the domain is what you just said, Cherise, right? Because I put these symbols underneath. Otherwise, I would have not chosen negative 2 and 2. So for me, if you present this or something similar, I know that you know what you're doing. You already identified the domain correctly. If you want to write it separate, you can. But I'm just trying to show you that you can present the graph of this function in 3 minutes or less. You don't have to, though. You take all your time you need, all the time you need. But you can write domain negative infinity to negative 2, union negative 2, 2, union 2 to infinity. So careful, there are rational functions that are defined everywhere. They are, but not this one. This one is not defined at 2 and negative 2. Do we agree?
I agree because of the bottom.
Correct. Correct.
Okay.
Good. So then is x equals negative 2 and x equals 2, are they VAs?
Where it doesn't cross?
Yes.
Yes.
Yes. X plus 2 cannot be simplified, stays. X minus 2 cannot be simplified, stays. So these must be vertical asymptotes. Then automatically I know this. But what I don't know is exactly. So I will be using negative 2.1, negative 1.9, 1.9, and 2.1. You can say, I don't like your method of plugging those in. That's fine. You can use it. You can put a function in the graphing calculator and determine those, if that's what you want. In y equals clear, everything you have. And now the function is, don't forget parentheses. X minus 1 at the top, divided by, in parentheses, x squared minus 2. I'm sorry, x squared minus 4. And now you can plug in the numbers with second and table. Don't forget to make sure that you have the ask mode for the independent variable. And go in second and table and plug in negative 2.1, negative 1.9, 1.9, right? 1.9 and 2.1. You don't have to reinvent the wheel. It's easier for sometimes to just plug it in and say get the sign instead of plugging the function in and plugging them. It's fine, same thing. So I see on the left is negative infinity, on the right positive infinity, on the left negative infinity, on the right positive infinity. That's all I cared about.
And can you just go, because you didn't do that in the last class, can you just do it the other way you did it?
Yeah.
Mm-hmm.
Yes. With negative 2.1, negative, so this is negative. With negative 2.1, this is negative, and this is negative. 3 negatives give us a negative.
Okay.
It's the same thing, right?
Right.
With negative 1.9, this is negative. Negative 1.9, this is negative, but this is positive. So I have positive. With 1.9, this is positive. This is negative. This is positive, so it's negative. It's the same thing. It's just that I showed you with the calculator versus no calculator.
Right. So again, for 2, let me just do 2.
I cannot use 2.
No. I'm saying I mean like just positive 2. Plugging it in. So it's 2 minus 1.
You cannot plug in 2. If you
you're
plug
supposed
in, if you plug in 2 here, you will get something over 0, and
Okay,
you will
well,
not be able to
I meant
find.
1.9.
Okay,
I was
that's
just
perfect.
saying that example
Yes.
too.
1.9 minus 1 is a
And-
positive number.
Right.
1.9 minus 2 is a negative number. 1.9 plus 2 is a positive number, and you have a negative.
So because it's
Yes?
one positive on top and a negative on the bottom.
Yes, whenever you divide a positive by a negative, or you multiply positives with one negative, the answer will always be negative.
But you still have a positive at the bottom.
The positive doesn't change the sign.
Okay.
Positive is never strong enough to change anything. The negative will always dictate. If you have 2 negatives, the answer is positive. If you have 1 negative or 3 negatives or 5 negatives, the answer will always be negative.
Okay.
Better, everyone? It's a very good question. Yes? Okay. So we know the signs. Now, what do you think about the end behavior and the horizontal asymptote? It's type 2.
So number 3 times
0, 0, 0. Y equals 0, horizontal asymptote. Okay, x-intercepts and y-intercept, and we can graph. How do we determine the x-intercepts? Set y equal to 0, but this is x minus 1 over x squared minus 4 equals 0. When is a fraction 0? When x minus 1 is 0, which means x equals 1. So I have to put 1 where it belongs and 0. What about the y-intercept? How do I get the y-intercept? Oh, very good. So we have to find f of 0. So this is 0, this is 0. The top is negative 1, the bottom is negative 4. Exactly, 1/4. Very good. So I write 1/4. It's all done. Now, can you determine extra points? Yes. Should you? Please no. Don't. There is really no need. Okay. Yes.
For that x-intercept,
Yes.
you have x0 and 1.
So y equals 0 for the x-intercept, and only this can be 0. If this is 0, the function is undefined. So a fraction is 0 only when the top is 0. So that's how we get the 1. So it's 1 comma 0. 0 for y, x, 1 for x, 1 comma 0. That's how we determine when we determine the x-intercept, we have to set y equal to 0. Whatever we get, it's going to be 1 comma 0. Or blah, 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 comma 0. Remember, we had the same discussion last time.
So much better.
I'll figure it out. Is that clear?
Yeah.
So remember the x-intercepts are on the x-axis. So y must be 0. When we determine the x-intercepts, y must be 0. And then when x is 0, y is 1/4. Is that okay with 0 comma 1/4? Yes? Okay. So let's discuss this and then graph it. From 0, dropping down to negative infinity. In the middle, from positive infinity, crossing the x-axis, crossing the y-axis, crossing the x-axis, and going to negative infinity. One more time. From positive infinity, crossing the y-axis, crossing the x-axis, and going to negative infinity. On the other side, from positive infinity, going to 0. One more time. From 0 to negative infinity, from positive infinity crossing the y-axis, crossing the x-axis, going to negative infinity. On the other side, from positive infinity, going to 0. When we graph functions with asymptotes, what do we have to graph first? The asymptotes. Okay, that's all I care about. We haven't talked about symmetry, but I'll talk about it in a moment. Okay? So first, how many asymptotes do we have to plot or graph? So we have two vertical and one horizontal. But this is an overkill, right? It's an overkill because it's the x-axis anyway. So now I have to graph -2 as the vertical asymptote, and x equals 2 as the other vertical asymptote. I have 2 points to plot. And what are those points? Here they are. 0, 1/4. Yeah, kind of difficult. And 1, 0. That's all I have. Let's start with this piece. From 0 down to -infinity. From 0 down to -infinity. The function does not, eventually we say it gets closer and closer to the asymptote. Okay, do not make it cross here, do not make it touch or cross, careful. From positive infinity, it crosses, and goes to -infinity. Positive infinity, crossing at 0, 1/4, crossing at 1, 0, and going towards -infinity. That's what we have between the two vertical asymptotes. And on the right-hand side, from positive infinity to 0. From positive infinity down to 0. So this is f of x, which is x minus 1 over x squared minus 4. With the graphing calculator, let's check. We already have it. It's in y equals. I'm cheating by simply looking at this little graph, so I'm going to change it into zoom 6 because I had something else in there. And here it comes. So it's coming from 0 down to -infinity, close to x equals -2. From positive infinity, crossing at 0, 1/4, crossing at 1, 0, going to -infinity, where x equals 2. And from positive infinity down to 0. This is incorrect. They're not overlapping, they're not touching, but the calculator is not perfect.
How do you do this?
In Zoom and 6 for the standard. Better? So what I like about this function is the sophisticated type of examples. They're, in my opinion, a lot of work, a lot of different issues that they present in real life situation. Look at this one. Okay, so we're going to read the question in a moment, but let's look at this function. What would you say, what type is this function? First of all, you'll say it's rational, right, because it has x in the denominator. And then we know 3 types, actually. We know 2. You didn't tell me whether you wanted to see the third type, but I want to see the applications. There are no applications with type 3, so, okay. So can you tell me what type of rational function is it? Type 1. It is type 1. Same degree over same degree. For same degree over same degree, there is a horizontal asymptote. How do I determine it? Leading, that's for the type 2. Leading coefficient, which is over leading coefficient, which is, so what would be the horizontal asymptote for type 1? 6.5. We see it over there. Okay. Good. So now let's see what the problem is telling us. It says, this function models the pH level, f of x, of the human mouth x minutes after a person eats food containing sugar. So if I simply look at this model, I have not read the rest of the problem. But if I look at this model, the x-axis is in minutes, and the y-axis is the pH level, which has no measurement unit, it's just a number. So the pH level, assuming it's 6.5, I take a piece of sugar. What happens in the first 6 minutes, the pH level drops dramatically till a certain level, and then it starts coming back to normal, slowly but surely. It takes hours or maybe an hour or whatever, and it gets closer and closer back to 6.5. This is a typical rational function. Okay, now let's see the question. Use the graph to obtain a reasonable estimate to the nearest tenth of the pH level from the human mouth, level of the human mouth, 42 minutes after a person eats food containing sugar. 42 minutes. Approximately what do you say? Yes, initially it was 6.5. It dropped dramatically in the first 6 minutes, and then it starts leveling off, surely, but slowly but surely. Yes. Part B. After eating sugar, when is the pH level the lowest? 6 minutes. 6 minutes later. According to the graph, what is the normal pH level of the human mouth? Perfect. What is the equation of the horizontal asymptote of this function? Why? So what is the concept of the horizontal asymptote? Eventually, the function will approach it. So it was initially 6.5, something happened, but it comes back to normal slowly, slowly. Eventually, as time goes by, it goes back to 6.5. This is the behavior of the function at the ends. In this case, only on the positive side. Use the graph to describe what happens. We already did. 6.5, dramatic decrease in the pH level. To what level? How much, roughly? 4.8, something like that, roughly. Okay. And then it starts coming back to normal. But look, it takes more than 66 minutes after we eat sugar for the pH level to go back to normal, or close to normal. Okay, let's look at another function. Right here. So in this problem, a patient is injected with a medication. So what is the concentration? And this model depicts the concentration of the medication in the patient's bloodstream. So initially he did not have the medication, antibiotic or something, whatever. So it did not. Look what happens, I don't know, I did not read this yet, but the concentration shoots to whatever level, and then it comes back to normal. And we expect that whatever we are treated with, eventually that medication will go to zero. Right, it will not stay, because if it stays, then we're going to explode, right? Because we, over the course of a lifetime, we take medications, right? What type of function is this? Times 2. Right, what is the horizontal asymptote? 0. Exactly. Because in this case, it does not approach like the previous example, 6.5. But we really hope that the medication wears off, right? And eventually gets back to normal, which is 0 in our bloodstream. Let's see what they want with this function. Use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. And now I look. 0, 10 by 1. 0, 3 by 1. 1, 2, 3. So it says find the concentration 3 hours later. 3 hours later. 1, 2, 3. 1.5. I would say 1.5. Yes. Part B. Use the function's equation to find the horizontal asymptote of the graph. We already did, because it's type 2, and it will always be y equals 0. Good. Here's another model. Oops. No one can see that. What am I doing? Right here. Okay, what type of function is it? Still rational because it has x in the denominator, but is it type 1 or is it type 2? Type 1. Right. What will be the horizontal asymptote? Yes, because 100 times x is 100 leading coefficient of 1. 100 over 1 would be horizontal asymptote is 1. And as you see, eventually levels off, getting closer and closer to 100, whatever that is. Any questions? Any questions? So what I would like, I know I only have like 13 minutes left. What I would like to do now is show you the very last section, which is only a little table, which is 3.6. And that will be the end of the material for test 2. And we'll go back on Wednesday and we'll do more problems on anything you want. Okay? And we'll review for the test. Okay, last section. 3.6, polynomial and rational inequalities. So polynomial and rational, this is the entire chapter. We've been talking about polynomial functions and rational functions the entire chapter. But this time we are interested in inequalities. Okay, so here's an example. X times negative x plus 2 times x minus 3 greater than or equal to 0. What type of inequality is this? You cannot say linear, you cannot say quadratic, but you must say it again. It's an inequality, but what type? It's not linear. Say it again. Exactly. Degree? Exactly, degree 3. We graph these functions, right? Okay, so here is what I recommend. Another table in which, oops, this is 11 actually. The first x will always be the variable in the problem, which goes from negative infinity to infinity. So we are solving, right? Solve the inequality. This is what we're trying to do. Solve the inequality. X is the variable in the problem. Then I have x as the first factor. Then I have negative x plus 2 as the next factor. Then I have x minus 3 as the next factor. And then I have the whole thing, x, negative x plus 2, x minus 3. Let's discuss this for a moment before we start. What am I trying to do? I'm trying basically to study the sign of each individual factor in the whole, that I can determine the sign of this, the whole thing. In order to study the sign of each factor, I have to find where the first one is 0. Where is x 0? For x equals 0, of course. Where is negative x plus 2 0? Negative x equals negative 2x equals 2. So for 2. Where is x minus 3 0? When x is 3. These are the only numbers I need in the table. The x-intercepts for all these pieces. This will cross the x-axis at 0. This will cross the x-axis at 2. And this will cross the x-axis at 3. Do we agree? So I put them in ascending order, 0, 2, and 3. Each row has to have a 0 somewhere. Under which number will I put a 0 for x? Under 0. Do you all agree with 0 under 0? Where will I put a 0 for negative x plus 2? Under 2. Where will I put a 0 for x minus 3? Under 3. But now I would like to put something under 0 for the whole thing, under 2 for the whole thing, and under 3 for the whole thing. Let's think for a moment. What goes in there? Say it again. No, because of all of them have multiplicity 1. So in other words, I'm asking when x is 0, what do I get here? Yes. How do I know? Because one of the factors is 0. Excellent. What do I get for 2? Right, because some other factor is 0. The second one is 0. What will I get for 3? Right, because the last factor is 0. If any of the factors is 0, the product will be 0. Okay. Let's think in terms of x. They're all linear factors. Does x look like this? Negative infinity to positive infinity, or positive infinity to negative infinity? Very good. That's all I need. Perfect answer. The next one. Does it look from negative to positive or from positive to negative? It has a negative leading coefficient.
So that will be positive
To negative. Very good. Last one. Does it have a positive leading coefficient or a negative leading coefficient? So it will come from? Very good. Negative, then 0, and then positive. It is very clear that we have 1, 2, 3, 4 subintervals. Remember, we are multiplying. We are multiplying a negative by a positive by a negative. So when I multiply two negatives, what is the sign?
positive.
Good. When I only have one negative, what is the sign? When I have two negatives, what is the sign? And when I only have one negative, what is the sign? Final step. I look here. This inequality symbol tells me what to pick. What sign is positive? What sign is greater than or equal to 0? What sign is greater than or equal to 0? Exactly. This must be positive. Where is it positive? Here and here, which means for this and for this. So x in the interval, negative infinity 0, union 2, 3. This is the answer. So if I want this product to be positive, I will pick x between negative infinity and 0 and 2 to 3. What if I reverse the inequality? And I say, what if I want this to be less than or equal to 0? What would you pick? You will pick these two. You will pick 0 to 2, union 3 to infinity. Questions? Does it make sense? Any questions? Let's look at the ratio, and we'll stop. Let's say x minus 1, x minus 3 over negative x plus 2. You dictate. You tell me what you want. What type of inequality? You want it greater than or less than? Let's say less than, without even the equal symbol. How many factors will you present in the table? 1, 2, 3. And x at the top, right? X is mandatory because I don't have where to put the numbers in if I don't write x first. So x minus 1, x minus 3, oops, sorry, and negative x plus 2. What is the last row all about? The whole thing, right? The whole thing. The whole problem, very good. X minus 1, x minus 3 over negative x plus 2. How many numbers will you give me to put in the table at the top? You have to give me a number for each factor. Which number would you give for the first one? For the second one? And for the last one? Very good. So 1, 2, 3. Where will I put a 0 for x minus 1? Under 1. Where will I put a 0 for x minus 3? Under 3. Where will I put a 0 for negative x plus 2? Under 2. But now, the moment of truth, I need to put something for the whole thing under each number. Very careful. What do I write under 1? Excellent, 0. What do I write under 2? Undefined. That's the only difference from polynomial to rational. Polynomials can never be undefined. Rationals can be undefined. What about under 3? What do I write under 3? Obviously 0 because it's at the top. Perfect. So please give me the signs, the sequence of signs for x minus 1. Sequence of signs for x minus 3. The same thing. However, for negative x plus 2, that's why we studied end behavior. It's a leading coefficient that is negative and an odd function, odd degree. Very good. For the first subinterval, remember if we multiply or divide, it doesn't make any difference. But I have to have products, right? And I do have a product and ratio. When I multiply or divide to negatives. Careful.
Positive.
Perfect. I know it's late. So when I have one negative, when I multiply or divide two negatives, and the last one, negative. Now the moment of truth. What do I want? Which sign is less than 0? I'm looking for positive or negative? Of course. So is this ever negative? Yes. For which x values? Yes, because there is no equal symbol. I cannot ever put a bracket. Secondly, I can never put a bracket no matter what at 2 because it's undefined. So x in the interval 1, 2, union 3, infinity.